If you have just one term, if you have just one term in the denominator, then you can just divide it. Oh, actually, so 3 and 9 can reduce to what?
1 and 3.
1 and 3. And then what's a squared divided by a? A.
Yeah.
If it's, and what's b divided by b? 1. And 1 times all this stuff is just all this stuff. So basically the b's just cancel out. So it's 1a over 3 or just a over 3. Okay. Number 3 is trickier. What's different on number 3?
They have more than one term.
Yeah, there's 2 terms on top, 2 terms on bottom. So when it has more than one term, what we're going to be doing usually is factoring. There's 3 main ways of factoring. Do you guys remember this? There's take stuff out. There's 3-term factoring, which we have done a lot. 3-term factoring. And then there's like a square minus a square. Okay. Can I do 3-term factoring on this? No, it's only 2 terms. Can I take anything out?
Yeah.
What can I take out on just the top? What goes into both of these? 5 and x. So what you do is you put 5x in front, and then in parentheses you put what's left if I divide both of those by 5x. What's left in the first term if I divide by 5x? X. Plus, what's left in the second term if I divide it by 5x? Y. Okay, leave that there for a second. What can I do to the bottom? Take a 2 out. If I take a 2 out, what's left? X plus y. Okay, here comes a very important statement. I think I've mentioned this before, but in passing, because we didn't have to do it very much. Actually, I'll come back to that. Does this simplify? No. Okay, you cannot, it has to do with order of operations, like adding is not the opposite of dividing, and anyway, this does not work, no. You could simplify if it's x and x times y, that does work. That'd be 1 over y. But basically, if you have an x plus y or an x minus y, if you have a plus or minus, just think of this as one thing. It only cancels out with something identical to it. So back to this problem, guess what's going to happen? The x plus y is those things. The reason is x plus y is a factor. It's a multiplied thing. And multiply and divide, they can cancel out. So the x plus y's can cancel out. But I could not have done x and this x canceled out. That would not have worked. So what's my final answer? 5x over 2. Okay. On number 5, what can I do to the top there? Take out a 6. Is that all I can do? Yeah, looks like it. No, not any letters or anything. 6 goes into both of the 30 and 42. So if I take a 6 out on number 5, what's left on the top? 30 divided by 6 is 42 divided by 6 is, and then on the bottom I have a 9 and n. Alright, what can I do? Not a lot. There's not a lot I can do here, but there is something I can do. Okay, yeah, the 6 and the 9. This 6 is multiplied, so it is free to be divided by this multiplied 9. So what do 6 and 9 reduce to if I divide them both by 3? 2 over 3. So we are not going to multiply that 2 out. We're going to leave it in factored form. In other words, we're just going to leave it alone. We're not going to put the 2 and the 5 plus 7 in together. That's what the directions tell us to do anyway. Leave it factored. Okay, number 7. X squared minus y squared over y squared minus x squared. Okay, what kind of thing is the numerator? X squared minus y squared is a square minus square. Do you guys remember how these worked? They were pretty easy. We haven't done them enough, so you probably forgot how it goes though. Basically, you just take the square root of each of these. Something squared minus something squared. So what's the square root of x squared? X. Those go in the front. What's the square root of, or what goes into y squared? Y times y. But you need 1 plus and 1 minus. That is always the pattern for square minus a square. Okay, how about the denominator, the bottom? Same thing, but the y is in front. So it would be y plus x and y minus x. Pretty similar. Okay, does anything cancel out on this one? Yeah, is x plus y the same thing as y plus x? Yes, it is. That's gone. Order of addition does not matter. It's the same value. Okay, is x minus y the same thing as y minus x? No. But they are related. Okay, let's do a little experiment up here. What if I did like 7 minus 4 and 4 minus 7? What's 7 minus 4?
3.
What's 4 minus 7?
-3.
Does that always happen?
Yes.
Yes. When you subtract numbers in opposite order, you get opposite values. So these are not the same value, but they are opposites. Do opposites cancel out?
Yes.
What's 3 divided by -3? -1. They cancel out, but they leave a negative behind. So this divided by this is -1. This divided by this is basically 1. -1 times 1 is -1. If there was something else in the answer, I basically would have just put a negative on the front. The negative would have been part of the answer. But since there is not everything canceled out, we have at least a 1 here. Anything divided by itself is 1. Alright, any questions on that one? Number 9. Okay, on number 9, the top term is, there's just one term, so we can't do anything to the top. What can we do to the bottom? Take out a 2, yeah, from both of these, and an x. The top stays the same for now. The bottom, a 2 and an x can come out. What am I left with if I divide this by 2x? The first term. X. Minus what's 6x divided by 2x?
3x.
3.
Or 3.
The x's cancel out, but 6 divided by 2 is 3. Okay, what can we reduce here?
No, 10 and 2.
10 divided by 2 is 5. X squared divided by x is, yeah, one of the x's cancel out, leaves one x on top. How about these two x's? Do these two x's cancel out? No. Think of x minus 3 as one thing, so it will not cancel out with the x. So the top I have 5 times x, 5x, and the bottom is x minus 3. Number 11. We're starting to get back into the 3-term factoring. This is your guys' wheelhouse, right?
No.
I wonder where the term wheelhouse came from. I imagine a baseball swing kind of makes a wheel. This is the sweep. This is where you like to hit it at. I don't know. It's iffy. You guys remember how these go? What multiplies, so if it's 3-term, a squared, a, and a number, you say what multiplies into negative 30 that would add up to negative 1. Or on the bottom, what multiplies into 10 that adds up to 7. So let's start with this. What can multiply into negative 30? Negative 6 and 5. Or 6 and negative 5. But how does it add, which ones add up to negative 1? Negative 6 and 5, positive 5. They multiply into negative 30. They add up to negative 1. Okay, same question on the bottom. It's another 3-term. So what multiplies into 10 that adds up to 7? What multiplies into 10?
5 and 2.
5 and 2. Do those add up to 7? Yes. So a plus 5, a plus 2. What cancels out?
A plus 5.
A plus 5. Anything else? No, it's not a trick question. So it's just a minus 6 over a plus 2. Okay. Before I go on, I probably should mention this. Do you guys know what a values could not be used on this problem? Any a values that would be no-nos? Negative 2 and negative 5. Why are they no-nos? Because dividing by 0 is impossible. It doesn't make any sense. So they wanted us to say like a cannot be negative 2 and negative 5. I'm not going to worry about that, but that is kind of something you need to keep in your noggin. Now this simplified to just a plus 2 on the bottom. So why isn't it just negative 2 that doesn't work? Because the original thing, the actual thing, negative 5 doesn't work. So if it doesn't work on the original, it doesn't matter what this one says. So in almost every way, these two things are the exact same thing. This and this are the same thing. Except for negative 5 doesn't work on the original. Whereas it would work here. But if it doesn't work on the original, it doesn't work at all. But anyway, that's that. That's what they mean by excluded values, but I'm not going to grade on it. 13. Remember, we talked about this in chapters past, but you also can't have a negative under the square root usually when you're plugging stuff in. 13. We're going to make it after all. Uh-oh. Oh no. What have you done? Okay. I don't want to write all that down. I'm doing it anyway. You guys remember how to do those on 13? It's a little bit more complicated, not too bad, but so something weird about the 13 is it has a b and a b squared on the end. You can kind of ignore that. We'll talk about that in a second. It doesn't affect it too much. The harder trick is that there is a number on the quadratic term, the squared term, that's not just a 1. There's a number right there. So that's going to make it trickier. But it still is 3-term factoring, so it is going to set up like that. Okay, instead of just putting a and a in the front, I've got to say what multiplies to get 3a squared. 3 and 1. So instead of just a and a, it's 3a and 1a on the front. Okay, on the back, I'm still asking what multiplies into 2, but I'm no longer saying that adds up to 7. I'm saying what multiplies into 2, that when we FOIL it, outside, inside, gives me this middle term, 7, AB. So what can go into 2? We'll start with that. What can multiply into 2? 2 and 1, right? Instead of just putting 2 and 1 though, because there's a b squared here, I have to put 2b and 1b. Now, do I put the 2b here and the 1b here, or the 1b there and the 2b there? Well, I want, when I do the outside inside, I want it to give me this middle term 7. If I put my 2b here, what does that outside give me?
6AB.
6ab. And then if I put my 1b over here, what's the inside give me? 1ab. 6ab plus 1ab is 7ab. So it's kind of trial and error. You gotta just plug stuff in and see if it works in that spot. So if there's a number on front, you have to check by doing outside, inside, like foiling. Make sure it gives you the middle term. Okay, the bottom is much easier. Why is the bottom easier? There's no number on the front. So what am I going to put on the front? A times A. That gives you A squared. This is a lot easier. For the back, all I have to do is ask what multiplies into negative 2. Okay, what multiplies into negative 2? Negative 2 and 1. Negative 1 and 2. But it has to add up to positive 1. So which of these adds up to positive 1? Negative 1 and 2. What did I do wrong? Yeah.
That doesn't add up.
It was b squared, not just negative 2. It's negative 2b squared. So this should be negative 1b, or negative b, and 2b. Does anything cancel out? Yeah, little hint, something will always cancel out in these problems. So if you don't find anything, you missed something. A plus 2b's cancel out. So the final answer is 3a plus b over a minus b. All right, 15. Are we having fun yet? Yeah. 2x squared plus 5xc. David.
I'm back. I wasn't ready. I want a piece of paper.
This one looks a lot like the last one. X squared. Okay, so for the top, again, it's 3-term factoring, so I'm going to set up my parentheses. What goes into 2x squared?
X and 2x.
X times 2x. What goes into negative 3?
Negative 3, 1, negative 1, 3.
Right, negative 3 and 1. or negative 1 and 3. So I want to get a positive 5 out of this, right? So how am I going to use 1 and 3 to do that? Okay, what if I put my 3 right here? What will that give me? 6. And then if I use a negative 1 right there, what will that give me? Minus 1. So positive 3, don't forget these are z's. So positive 3z and minus 1z. And the bottom looks easier because there's no number on the front. So what goes into x squared? X and x. Okay, what goes into negative 3 that can add up to 2? What multiplies into negative 3 that adds up to 2? 3 and negative 1. So it's plus 3 and minus 1z. Josie's not here today. Is she the only one that's gone? Yeah. Okay. What cancels out?
X plus 3z.
Anything else? No. Seeing if I can make you think it did cancel out. It doesn't.
What number are we on? And so the 3 gets the negative 3 plus 1.
All right. Same thing. Well, actually something different on this one. I copied the right problem, didn't you? Okay, you guys see what's different on the top on number 17? Yeah, h cubed instead of squared. And you technically you should always check this, but can I take anything out of the top? A and a 3, yeah. All 3 of these terms have at least one A, and they all 3 can go into all of them. So if you can take something out, you should do that first. What's left if I take a 3A out of the first term? A squared is still left. What if I take a 3A
Plus 2ab
and a 3A out of this?
plus b squared.
Okay, that's actually kind of good news. I mean, we still have a 3 term here that can factor, but it's going to be a lot easier. Can I take anything out of the bottom? 6,
B.
A, B. What's left if I take 6AB out? I get an A left on that first term, and I would still have a B left on that second term. Okay. That top parentheses is still a 3-term polynomial, so I can probably factor it, is what that means. Not necessarily always true, but probably the way these books are set up. So what am I going to put in front? A times A. What am I going to put in the back? What goes into B squared? B times B, or it could be negative B times negative B, but it's supposed to add up to 2. So just 1B and 1B. So it's just A plus B, A plus B. The bottom, 6AB, A plus B. What cancels out? One of the A plus B's. 3 and 6 reduces to 2 on the bottom. And just the A, yeah. So what does that leave me with? Not a lot. A plus B on top and 2B on the bottom. To be or not to be? That is the question. Whether 'tis nobler, and that's all I got. You guys have to do Shakespeare in high school?
We're gonna have to read Hamlet next year. No, we read Macbeth. That sucked.
It's kind of impressive, wasn't it?
He like killed his friend, he came back.
Yeah, I didn't even
Ghost.
read it, cause
Oh,
I
yeah.
was just like, I read like, I got like halfway through it, and I was like,
Hey, John.
I don't know. I wasn't paying attention. We're watching a movie because we can't volunteer. I seriously don't know what the original plan is, and like, I think I laughed. Oh, that has to be.
Actually, for time's sake, we'll just go to 18, that's fine.
oh, what a guy.
What a champ. Okay, David and Nick, this will be due when you guys get back. So you probably want to do it before you leave. Also, David and Nick,
Yo,
tomorrow's assignment is pretty similar to today's, but it's
Okay.
figured.
But this one's already like huge.
Page 389, 1 through 18.
Imagine being gone for like long periods.
Imagine being loved by your parents.
dang, he got you there.
I thought the joke was your parents.
My parents still love me. Wait, yeah.
It's getting dark. Let me turn the recording
like
on.
Just 'cause I'm around.